Hello friends, my name is Pankaj Pawar. In today's lecture, we will discuss regarding some basic thermodynamic devices like heat engine, refrigerator and heat pump. So we will start with the heat engine first. So we will go for the heat engine. So heat engine is a work producing device which is also thermodynamic device and used for the production of work with expenses of heat input, and remaining heat will be rejected to the surrounding. So we'll have a simple diagram of this heat engine like this. So here we have a source at T1 temperature from which heat will be given as an input to heat engine, which is nothing but the Q1. Out of this, some energy will be produced as a work, and remaining heat from Q1 minus W will be rejected to another part which is sink at temperature T2. So heat will be taken from this source at T1 temperature as a Q1, and rejected heat to sink will be at temperature T2. So Q1 minus Q2 here is nothing but work produced from the heat engine. As we discussed, this is a work producing device, so we are going to check its performance with the help of efficiency of the heat engine, which is nothing but work output of the engine, that is W, divided by heat input Q1. So here we have a work output W is Q1 minus Q2 divided by heat input as a Q1. So here we have the equation like this: 1 minus Q2 upon Q1, that is efficiency of the heat engine. So this is the basic formula to find out the efficiency of the heat engine. So you can observe here the direction of arrow is outward. So here from engine work is produced. So this is a work producing device operating in a cyclic process. Now next device under consideration is a refrigerator. Refrigerator is not a work producing device, it is a work consuming device. Here we have a surrounding at temperature T atmospheric. In between this we have a refrigerator as a device where we are going to supply work as a input, so W, and on the other side here we have space to be cooled, whose temperature will be less than atmospheric temperature. So from space to be cooled, heat will be taken as a Q2, work input will be given as W, and here Q1 amount of heat will be supplied to the surrounding. So main aim of the refrigerator is to cool the space. So here important parameter is, or desired effect is, the Q2. So amount of heat absorbed from the space to be cooled is Q2. Then W is a work input, and Q1 is the addition of W and Q2 that will be rejected or supplied back to the surroundings. So this is a simple refrigerator as a device, work consuming device. Now next to this we have uh, another device as heat pump. This heat pump is also work consuming device. It is also not the work producing device, but the main aim of the heat pump is to heat the space. Like refrigerator is used to cool the space, this heat pump is used to heat the space. So here we have a surrounding at atmospheric temperature, space to be cooled which is at higher temperature, space to be heated at higher temperature, and here work input given as W. This is nothing but a heat pump. So in this case Q1 is desired effect. So for heat pump, amount of heat given to space to be heated is the desired effect, while in case of refrigerator Q2 is the important parameter, which is the heat absorbed from the space to be cooled. So based on this we are going to check the performance of such devices. So that performance of the devices will be checked with the help of coefficient of performance, which is called as a COP. So COP is nothing but desired effect upon work input to the system, W. So for the refrigerator we know desired effect is the Q2. So Q2 divided by Q1 minus Q2, this is the formula for the COP of the refrigerator, while COP of heat pump is equal to desired effect is the Q1. So Q1 is the divided by Q1 minus Q2. This is the formula for COP of the heat pump. So for the same temperature limits we have the formula for COP of heat pump is equal to 1 plus COP of refrigerator. So desired effect in case of heat pump, as we discussed, is the Q1, and in case of the refrigerator it is Q2. So difference between these two devices is to have a function. So heat pump function is to heat the space and refrigerator function is to cool the space. So example, like to cool the food storage space refrigerator is used, and to have a water heating system heat pump can be used as a heating device. So as we discussed, in case of heat engine we will check the performance with the help of efficiency. So we'll write down the formula for all these three. So for heat engine, we have a efficiency as work output, that is Q1 minus Q2 divided by Q1, where Q1 minus Q2 is nothing but the work output and Q1 is the heat input to that engine. COP of refrigerator is equal to desired effect is Q2 divided by Q1 minus Q2, and for heat pump we have desired effect as Q1 divided by Q1 minus Q2. So these are the three basic relations to find out the efficiency and coefficient of performance of these three devices. So we'll discuss in detail regarding the refrigerator and heat pump in next lecture. If you have any doubt regarding this, you can comment in comment section. Thank you.